Started. So today we are covering a derivatives overview. Nothing new in theory today. We're just going to do some really complicated derivative calculations to make sure we're clear on what order we apply all of our derivative rules and how to apply them when we have like multiple chain rules together. Today, the pipeline project is due, so if you've got it done, throw it in the folder. I do take projects late for various penalties. If you think you can get more than 5 points on this project by holding it until Friday, or until Wednesday, then you should do that. 5 points off if you turn it first thing Wednesday. Steel drum is 5 points off if you turn it now. I've given back all the ones that were turned in on time. Coming up later this week on Wednesday is our review day for test number 2, which is scheduled for Friday. Any questions on the calendar? Okay, and then don't forget there are no classes tomorrow. Hopefully you come in anyway and meet with your advisor for advising day and get registered for the spring, possibly also January if you're into that kind of thing. So that's why we have no classes tomorrow, is so that folks can come in and meet their advisor. Yeah, there's like a 3.5 week, very short semester in January. Yeah, it's in the same schedule book, and I think so. No, I thought they typically have one of those. We can look. We can look. Okay, so here we are on page 56. So here is a something. All right, quick look at the strategy guide. Okay, so here's a pop quiz. Don't worry, it's not graded, but go ahead and fill in the derivative rules for each of those things in that table. Okay, so you can check your answers with mine up on the board here. Those are our basic derivative rules. You took a quiz on this already, and most of us got 100, which is great. So reading the paragraph right below, it says if a function doesn't look exactly like one of these functions, then we can't use these formulas. Instead, we have to use one of our other formulas first, like maybe a product rule or a quotient rule, or it's a chain rule, or it's a constant multiple times a function, right? And so it's not enough to just know these ones in the table. We also have to know what to look for to identify which of the other rules we should apply. So we're not going to read this whole thing through. I think it's a nice reference for you to check out later on. So I'm just going to, what am I going to do? I'm going to come down here. Let's look at the product rule. It says, so there's the product rule written out in symbols. And what are you looking for? Does the function consist of two functions which are multiplied together? If so, you're using the product rule. You use the rule to find the derivative of the product. A couple of cautions: the derivative of f times g is not simply f prime times g prime. Some of you are going to try this on Friday's test. It is not going to work out well for you. I'm hoping to jump in right now and say, please, please, please don't just do f prime times g prime on Friday. It's not right. So we have to recognize it is a product and it has that fancy rule. If you have something like cosine x to the fourth, that is not a product rule. It is not cosine times x to the fourth. That is cosine of x to the fourth. So that is a chain rule of the form cosine of stuff. So like everything with parentheses is not a product rule. We just have to really understand composition of functions, which is what this is, versus the product of two functions. And then if you have a product inside part of the function, you got to make sure you don't jump the gun and try the product rule too early. So maybe an example of that, if we can find one on the next page. So you can read through that later on. I think, like I said, it's a good reference. For example, if we take a look at the very last one here, it says ln of x to the fifth cosine of x. For sure, there is a product rule in this problem, but the product rule is not the first thing we're supposed to do in this problem. Ultimately, this is a composition. It is ln of some complicated stuff, right? So fundamentally, the first thing to do here is ln. And so what's the derivative of ln of stuff? It's 1 over the stuff times the derivative of the stuff. So 1 over all of that stuff. It's written out here in the right-hand column. 1 over all of that stuff. And then I get to look at the product rule, because now I'm taking the derivative of x to the fifth cosine x, okay? And so just because there's a product doesn't mean product rule. Again, today is all about like figuring out the rule, but also applying the rules in the right order. What about this guy right here? I see sine of stuff. Is that the first rule that we apply here? No, what's the first rule for that one? That is a product rule. That is e to the x times sine of 5x. So the product rule will guide us. And in doing the product rule, at some point, it's going to say times the derivative of the second. That's a chain rule. right? Sine of 5x is a sine of stuff. So we will apply the chain rule, but only when it's time in the middle of the product rule. What's the fundamental rule for this one? Is it a quotient or is it a product? It is a quotient, first and foremost. Like don't get lost in the details. Don't look at all the details here or here. Just say, yeah, it's two functions divided. And that's the quotient rule. And then in doing the quotient rule, you're going to have to start looking carefully at, well, what's the derivative of the top and what's the derivative of the bottom? And when you get to the derivative of the bottom, you say, oh, that's a product rule, whole separate detour to do the product rule for just the derivative of the bottom. Okay, I see sine, I see a fifth power. Is this sine of stuff or stuff to a power? This is stuff to a power, right? Stuff to a power. And so you bring the 5 down, you copy the stuff, you make it a 4, and then you finally get to look at the stuff and take its derivative. And so 5 sine of x to the 4th times the derivative of sine. That's the cosine sitting at the end. The one right above it, is that sine of stuff or stuff to a power? That is sine of stuff, right? Sine is the outermost thing, and so the derivative of sine is cosine. And so the first thing we do is cosine of that stuff. We just copy it as it is. And then finally, you look in there and you multiply by its derivative. That's the 5x to the 4. Okay, working back up here, that's just a quotient rule, nothing too fancy. That's a product rule, nothing too fancy. This one here looks so simple, you might even wonder why it's here. Well, there is something fundamental happening. Before it's a 15, it's really a 3 times, right? Like it's a 3 times the derivative of x to the 5th. And the derivative of x to the 5th is 5x to the 4th. And that's where, yeah, so this is really writing it out in its details. And then you can multiply the 3 by 5. But constant multiples are great, but you copy them, they don't disappear, right? Constants added, they disappear, but constant multiples stay. Okay, and then this is the nicest one up here, plus signs, you get to just do your 2 separate derivatives separately. Okay, so you can check that out later too. We're going to do, I think it's 2 of these guys here. So let's do these ones together. So we are differentiating, that means taking a derivative of g of x equals the square root of 2 raised to the power x ln of x. Okay, so I see an ln. I see a product up there, right? X times ln of x, that's a product. But before I see either of those things, I see a number raised to this stuff. And so in my mind, I have translated this thing here into finding the derivative of a number to the x. That is the fundamental one we're going to apply. And the derivative of this guy is a to the x times what? ln of a. So that's our basic rule that we're going to apply. In our example, what is the value of a? That's the square root of 2. It's just a number. Just a number. So we apply our rule here. So let's give ourselves a good derivative notation thing to start. G prime of x equals. Okay, so a to the x, square root of 2 to the all of that. It's not just x, you just copy it. Times, just like over there, ln of square root of 2. That would be the end of the problem if this original power had simply been x, if it was square root of 2 to the x. But it's more complicated, so the chain rule comes in and says multiply by the derivative of the stuff. Stuff is highlighted up there. We're going to put its derivative right over here. What rule for x ln of x? That's a product rule. So first times derivative of the second, first times derivative of ln of x, that's 1 over x, plus second times derivative of the first, copy ln of x. What's the derivative of x? Just 1. What am I missing? Okay, parentheses. The derivative of the stuff. It's 2 terms, but it's one thing. It's derivative of the stuff. You'll never go wrong by putting the derivative of the stuff in parentheses. Okay, I think that's it. The only simplifying I see is x times 1 over x. That's just 1. But I don't see anything else we can do. And then don't write the times 1 at the end. Yeah. Okay, let's move on to part B. Y equals, everybody got this one? Yeah. y equals e to the cosine of ln of x squared plus 1. So we got lots of functions within functions within functions, and we just have to figure out what is the fundamental outermost function here. What is it? It's e to the stuff. So let's apply our e to the stuff rule. So y prime equals, okay, so the derivative of e to the stuff is e to the stuff times derivative of the stuff. So we just copy the entire thing in all its glory, ln x squared plus 1. So that's the e to the stuff. And then we're supposed to multiply by the derivative of the stuff. So I'm going to underline what the stuff is right here. That's in green right now. And so the derivative of that, well, that's still complicated. Is that fundamentally an ln or a cosine? That's a cosine, right? The ln is inside, is buried right now, so I'm not even focused on it yet. I just see cosine of some stuff. So what's the derivative for cosine of stuff? Is negative sine of the stuff you copy at one time, all of that. The e does need to be there in the first part. Yeah, no e on the second one, because here we're just focused on what's underlined. So cosine became negative sine. Okay, so cosine of stuff becomes negative sine of stuff times the derivative of the stuff. Stuff has just changed roles, I should say. That's the new stuff now. Yeah, so ln of stuff, that's yet another chain rule. So 1 over the stuff times the derivative of the stuff. I'll underline, I think I've got another color here. Maybe black is good. This is now the last stuff, and the derivative of that last stuff is 2x. That's it. Yeah, this is all multiplication, and each of those things that are different colors are all one single term, and so you don't need any parentheses, but if you wanted to be really safe, you'd be putting parentheses around each of those different colored things. Yeah, good. Okay, questions on that one? All right, so we're going to break our tradition. My tradition is that in class we never work on homework, it's only activities and then even more practice. So we're breaking that tradition. You're going to work on your homework for the rest of this class. So here is your homework. It's going to be 1 to 73 odd from the review exercises. Now don't take your book out, I photocopied these things on the next page. So 1 to 73 odd at the end of chapter 3 of your book. So here is what you need to do. So 1 to 73 odd, that is 37 problems. I don't need you to do 37 problems. That's a bit of overkill. So in order to get full credit for this homework assignment, you need to do at least 20 of those 37 problems. But please, please, please don't do the first 20 because those are the easiest 20. Skip around. Find functions of different forms. Find the ones that look the most frightening to you. Do those, right? Do those ones. If you can do more than 20, that's probably better than doing 20, but 20 is our bare minimum, okay? 1 to 73 odd. If you take a look there, photocopied there, or scanned there, and then if you go a couple of pages down the road, you will find the answer key scanned. The answer key has simplified answers. Your answer first time around might not look exactly the same as that one. You can try simplifying yours if you really want it to look like theirs, or you can just show it to your neighbors or show it to me, and I'll tell you whether or not it's good. So I'm not about simplifying today, but you might have to do some of that to confirm your answer with the key, okay? All right, I will walk around, raise the flag if I can help.